All right, so this is Unit 6. We're going to start talking about square root functions, but we're also going to take a look at cube root functions today. So this is the introduction to irrational functions. So your check-in question for today is, welcome back. What is one thing that you plan on doing differently if you could this year? So you may have already gone over that, not sure. But today we're going to look at graphs and we're going to look at the properties of irrational functions. So we're going to start with a warm-up lesson on irrational functions, and then we'll practice a little bit. Now, this lesson and pretty much every lesson after this point is best copied into your paper notebook, and quite a few lessons from before this, but yeah, let's go ahead and get started. So your warm-up for today is find the inverse of the following function, y equals x squared minus 9. Okay, so remember to find an inverse, you switch x and y and then solve for y. So pause the video, work this out, okay, and you can go ahead and play it when you're ready. And you should have already done the problem before me going over it. So when we're working on this one, the first step is we are going to go ahead and switch x and y. And the next step is we're going to go ahead and solve for y. So that's the next step. So if we're solving for y, I need to get the 9 to the other side by adding it. And because I have y squared, I want to get y all by itself. So to undo a square, we're going to square root both sides. All right, now when we square root a different value, this is going to end up being the inverse of f of x equals plus or minus the square root of x plus 9. Now, the interesting thing about this is that this unit is talking about functions. If I were to graph this, this would look like 1, 2, 3, 4, 5, 6, 7, 8, 9, because it shifts 9 over left. Okay, this is going to be positive, positive, and this would be the negative, because we're taking an inverse of the original parabola. So this is no longer a function because it doesn't pass the vertical line test. So what we're going to focus on is just one side, usually one side of our square root. So in this unit, you may see that we are only going to work on plus square root of 9x plus 9, and just the positive side. Otherwise, if we look at the negative and the positive at the same time, it would end up being irrational, and that's why this lesson is talking about irrational functions. All right, so let's go ahead and take a look at an introduction to irrational functions. I went ahead and typed this out. You can go ahead and add that to your notes. So irrational algebraic function, a function in which independent variable appears under the radical sign or a power with a rational number for its exponent. So when we're talking about rational numbers, remember those are fractions, so like a over b or 1/2, 1/3. We're going to see 1/3 and 1/2 today as an exponent. So when we're looking at our radical, another way to rewrite this is a 2 is inside our radicand, so we can rewrite that as x to the 1/2. All right, now whenever we have fractional exponents, the denominator is always going to be what's inside the radical here, okay, and then this numerator is what's going to be squaring it. That's going to come into play in future lessons, but not quite this unit, so don't worry about the numerator just yet. For right now, if you have a denominator, that's what's inside the radicand. Because remember, when we're taking the square root of a number, like 25, we're seeing what groups of two numbers are the same. There's an imaginary 2 right there, because we're looking for a group of two 5s. And we'll talk about cubes in a moment. So let's go ahead. It's asking us to go ahead and substitute those values in for the square root. Now, what we're doing is we're basically stating f of negative 1 equals the square root of negative 1. We're substituting our x value, which is just negative 1. Hey, we just talked about this. This square root of negative 1 is not a real solution. It's actually just going to become imaginary. All right, so that's for just negative 1. The next one is the square root of 0. The square root of 0 is just 0. The square root of 1 is just 1. The square root of 2, I do not know off the top of my head. So you're going to go ahead and calculate the square root of 2. And I can do that here. Alright, so I went ahead and pulled up my calculator and I had to type in 2 square root, and that gave me 1.414. So that's going to be the value that I'm going to plug in here. So it's going to be 1.414. And then I have the square root of 3. So we would start off with, let's see if I can pull that up again. The square root, so 3 square root would be 1.732. And the square root of 4 is just 2. Square root of 9 is 3. So those are pretty simple to graph. All right, now it's asking what domain and range of your graph. So when we're looking for domain, remember, it's been a while since we've seen this. These are all the x values and range is all the y values. And we're going to go ahead and do that in inequality notation. So we're looking for domain and range. Basically, let's wait until we have a graph, because I'm going to show you that it's easier to see the graph once we have it. So we're going to go ahead and just put some of our points here. Now, looking at the x values and the y values, my greatest x value is 9, so I'm going to go ahead and go out 9 spaces, or units out. 1, 2, 3, 4, 5, 6, 7, 8, 9. We're going to go ahead and number those. Okay, and another point, the highest y value I have is 3. So I'm going to go ahead and make them 1, 2, and 3. So I know I'm going to end up having a point at 3, 9, because that's our last point. And then I'm going to just work backwards this time. And 4, 2, 3, 1.7, so halfway but a little bit higher. 2, 1.4, halfway but a little bit lower. 1, 1, okay, and then 0, 0. And then we cannot graph our imaginary square root of 1. So we're going to go ahead and start here, and we're going to go all the way out. Whoop. And it's like a parabola that's been, it literally is just part of a parabola that has been reflected across y equals x-axis, because remember, that's the inverse. Now, when we're looking for the domain and range, okay, we want to look for the lowest x value to start off. So our lowest x value in this case is going to end up being 0. And because we're using inequality notation, we can set it equal to 0 on this one because it is a solid circle. X less than or equal to, not equal to, because our greatest goes all the way to positive infinity. So that's going to be less than infinity. All right, now for our range, which will be our y values, we're going to look at 0 less than or equal to y, which is less than positive infinity, because it starts off at 0 and it continues to go up all the way to positive infinity. Okay. Now it says write the equation for the inverse function of y equals x equals the square root of, f of x equals the square root of x. And what we're going to do is we're going to switch x and y first. Remember, f of x is just a fancier way, or the way of writing y. Oh my goodness, go away. All right, so when we're looking at this, this would end up being y equals the square root of x, but now we're going to have x equals the square root of y. And we need to go ahead and solve for y. So we're going to square both sides to get rid of that square root. Whenever we square, we're going to end up with y equals x squared. Hey, check that out. That's our parent function for a quadratic. So the inverse of our irrational function is really the quadratic, and they have a relationship that they have going back and forth. So the inverse of f of x is just x squared. All right. So I'd love for you to pause the video, ask any questions that you have to the person in the room, and let's go ahead and move on. So we're going to take a look at a cube root function, or a so if you see that it's x equals 1/3, another way to write that is just f of x equals the third root of x. And that means that we're looking for groups of 3 this time, 3 numbers that are the exact same. Now, the cool thing about cube roots is if I take a look at -8 and I break it apart, I have 2 times 4, and we can say negative, and then we would end up with -2 times -2 to be positive 4. Notice how all 3 of those are negative, okay? Because the cube root of -8 is -2. And we can check that with our calculator if it'll let me. Here we go. Let's see if this one has anything other than what we were given. Aha! Nope, it's not working right. But the cool thing about a regular calculator, standard calculator, as long as it has parentheses, trying to use this one so that you guys can see it, we can say, okay, let's have -8 on the inside, close parentheses. And now I'm going to go ahead and have that to a power of, in parentheses, 1/3. So 1 divided by 3, close parentheses. Alright. It did not like that. Oh, and then you press enter because it actually calculated the 1/3. So your answer is 2, because -2 times -2 times -2 is going to give you -8. Alright, so let's go ahead and take a look back at our whiteboard. We're going to start off with -1. So what times what can give us -1? And it's just -1. And then the cube root of 0 is going to be 0. The cube root of 1 is 1. 1 times 1 times 1 is 1. And the cube root of 8 is 2. 2 times 2 times 2 equals 8. So when we're looking at domain and range, it's best if you go ahead and graph your points. So we're going to start off with the highest and lowest values. For the x values, I noticed that I need to go all the way to -8 and +8. My highest and lowest y values are going to be 2. So we're going to go up to +2, down to -2. And I have a point at 0, 0. So here's 1, here's -1, 8, 1, 2, 3, 4, 5, 6, 7, 8. Nope, darn it, I didn't make it. I'll just go ahead and erase this one, and this is now 8. 1, 2, 3, 4, 5, 6, 7, 8. Alright, it'll be slightly skewed, but that'll be okay. This is going to be -2, 8. That's my first point. -1, -1. So that's going to be about right here, right on top of the 1 that I've drew. Then the next one is going to be 1, 1. And 8, 2, which is out here. So it's going to create this S shape, but notice how this is going to look like a parabola just from 0 all the way to +infinity. This is also going to be kind of like a parabola, but going in a different direction. And this is your cubic function. Now, when we're looking for domain and range on this one, so we have x values and y values, it's going to continue on, if we're looking at the x values, from -infinity all the way to +infinity. So this is actually going, our domain is going to start off, the lowest x value is going to be infinity. I cannot include infinity, so that's why it's going to be a less than sign, less than positive infinity. Then the range is my lowest. This is going to continue. It looks like it flatlines, but it actually continues down as well. And it's also going to continue up to positive infinity as you continue on to infinity. So it's going to start off in infinity and end in positive infinity. But we can never include infinity because there's always infinity plus 1, so that's why it's not equal to. So now we're going to write the equation of the inverse of f of x equals x to the 1/3. So if I do have that, what I would do first, and I'm going to leave this in fraction form so we can see it in a little different way. So we're going to end up with y equals x to the 1/3, but I'm going to switch it, so it's x equals y to the 1/3, and we need to go ahead and solve it. Now, I can do a power to a power, because this would be meaning I would multiply, and multiply by the reciprocal. So if it's 1/3, I would multiply by 3/1, which is the same thing as saying cubing. So this is the cube root, and we're multiplying by the cube, which is just by 3. So these fractions would simplify because 1/3 times 3 is going to give us 1, and this is going to leave us with x to the 3rd equals the inverse function of x, which you can simply rewrite as the inverse function of x equals x 3rd. Alright, here we go. You can pause it if you need more time to write any notes. If I'm going too fast, just please let the person know if it's being played in the room to pause it for you to write some more notes. Otherwise, keep going. So the square root function is, the parent function for a square root function is just y equals the square root of x, or the f of x. The square root of x. Now, when we talked about this at the beginning of the school year, we talked about parameter changes as far as the equation moving left, right, up, and down. And the way this equation moves left, right, up, and down is we first have our scale, which reflects it about the x-axis, depending upon if it's positive or negative, but it also controls the horizontal stretch on your graph. So on the inside of the radical, we would have x minus h. X minus h changes direction left and right, but opposite what you think because the equation does have a negative, so it switches the direction on you. Come back. No, seriously, come back. Okay. So I'm going to erase that little arrow. And then we also have plus k on the outside of that radical. Looks a little long. Okay. This is going to be your vertical shift, so up and down, depending upon positive or negative on your graph. And those are going to be your parameter shifts when we're talking about square root functions. So okay, so when looking at this equation right here, f of x equals 3 plus 1/2 x plus 2. Let's get it in a format that we know what to do with. So we're going to put k, or constant, that's kind of in front here. We're going to put that in back. So I'm going to go ahead and rewrite this as f of x equals the square root of 1/2 x plus 2 on the inside and plus 3. Now later on we'll talk about parameter shifts, but for right now we're going to go ahead and take a look at where are there no real values for the function. Now, if we're looking for no real values, remember anything inside the radical, it has to be greater than 0, because if it's less than 0, then we're going to end up having imaginary solutions or imaginary numbers happening inside of that radical, and that would give us imaginary numbers. So what we're going to actually do is we're going to take what's inside the radical, 1/2 times x plus 2, and set it equal to 0. Because we really want to see where it's going to end up being And I apologize, it needs to be greater than 0, not equal. Greater than 0. We need to see where that's going to be greater than 0. So the first thing that I'm going to do is I'm going to get rid of this fraction by multiplying both sides by 2. So when I multiply 1/2 by 2, that's the reciprocal. It just becomes x plus 2 is greater than 0, because 0 times 2 is just going to give us 0. Now, next step, subtract 2. X is going to be, has to be less than 2. Okay. So when x is less than 2, that means we are going to end up with no real values for the function. Now the next thing that we're going to look at is give the domain of x. If f of x is to be real numbers. So that means that if it's non-real, if it's less than 2, that means it's going to be real if it's greater than 2. So our number that we're starting off with is 2. So x has to be greater than 2 or equal to 2. And then we're going to end up having all the way up to positive infinity, because it's going to continue all the way. Now we're going to give the range for x. Now if we're talking about range, we're talking about how the y values. Okay, so looking at the parent function, our parent function is normally 0 less than or equal to y less than positive infinity for the square root, because we talked about that on that other page. Okay, but if we're talking about this transform equation, notice how the entire equation shifted up. So it used to be here, now it has shifted 3 up. So if we're starting out and it used to be 0, 0, and now it's at 3, we're going to end up starting at 3 for our y value as well. And it's going to go all the way to positive infinity. And this is going to be our transformed. Okay, I know I missed a letter there. Transformed function. Okay, now the next one is we're going to go ahead and find f of 14. So f of 14 just means that 14 is our x value. Okay, so we're going to look for where x is 14, and we're substituting it in. It's already written there. 3 plus the square root of 1/2, 14 plus 2. Okay, so 14 plus 2, that's going to give me 16. 16 divided by 2 is going to give me 8. The square root of 8 is a decimal. So I'm going to go ahead and take that decimal, square root of 8 plus 3. And that's going to give me 5.82. I want to double check real quick. Plus 3. Yeah, is 5.82. But that's going to round that third number up to 3. So we would end up with f of x, or f of 14 equals 5.82. Alright. Now it's going to ask us to find the x value if f of x equals 8. So in this case, remember, f of x is a fancy way of saying y. So it's really asking if y equals 8, what would the x value be? This is a tricky SAT question sometimes, because some students will look at this and say, okay, f of x equals 8. So that means, okay, I'm going to go ahead and just substitute 8 in and solve for it. That does not mean that x equals 8. It means y equals 8, and you have to substitute it in for f of x. So wherever you see f of x, that is your 8. So I'm going to go ahead and just rewrite the function. Alright, what we're going to do next is we're going to go ahead and substitute instead of f of x. We know now they told us it's 8. Next step, we're going to subtract 3 to both sides. That becomes 5 equals the square root of 1/2 times x plus 2. Now if I have a square root, the inverse of a square root is to go ahead and square both sides. So we're left with the square root and the square cancel each other out, they simplify. Okay, and that would just end up being 1/2 times x plus 2. In order to get rid of this fraction, I'm going to multiply this side by 2. That simplifies this out. Okay, 2 times 25 is going to give us 50 equals x plus 2. We're going to subtract 2. That's just going to give you 48 equals x. So we now know that f of x, or if we were to rewrite this as f of 48 equals 8, our x value is 48. All right, so let's go ahead and take a look at the x-intercept. If we're finding an x-intercept, that just means that it's going to cross the x-axis, and at any point on here that's on the x-axis, we have the x value, but our y value will always be 0. So when we're substituting, when we're trying to find a y-intercept, an x-intercept, we're going to substitute y equals 0 into our original formula to figure that out. So let's go ahead and rewrite that again. So we have f of x, but instead of, we have f of x equals 3 plus the square root of 1/2 x plus 2. Since I know y is 0, remember f of x is just another way of saying y. So I'm going to substitute 0 equals 3 plus the square root of 1/2 x plus 2. And we're going to go ahead and simplify or solve it. Solve for x. All right, now at this point, we would go ahead and take a look at a square root equaling a negative number. Can a square root, the whole what's inside the radical, equal a negative number? No, it doesn't work. I can tell you that right now, because when we do this step and we square both sides, this is going to become positive. So it's going to be positive 9 equals 1/2 x plus 2. Okay, and if we have a fraction on the outside, 1/2, we are multiplying both of these by 2, and that would just become 1. This becomes 18 equals x plus 2, and x would equal, subtract 2 over, that would just be 16. Okay, and the reason why this will not work is because when we're looking at this as far as x equals 16, we can substitute that in to our positive function, and it's not going to give us our value. So we could say, okay, it's not going to give us 0. So if we substitute it back in, we'd say 3 plus the square root of 1/2, 16 plus 2, that's 18. Half of 18 is 9, square root of 9. We want this to equal 0. So we would end up with 3 plus the square root of 9, which is just 3, equals 0, because we're only looking at the positive square root, and that is no solution. And the reason being is, actually, when we get to h, well, we're going to say no x-intercept here, not for the positive radical. And the reason being is we're going to go ahead and shift the parameters. This is going to go left 2, and then up 3, 1, 2, 3. And then our graph is going to go out this way, and I'm going to go ahead and plot another point just to kind of see what's going on, because that 1/2 is going to stretch it. So if we were to go ahead and plug in, say, 0 and see what's going on that y-axis, our original one is just going to end up being 0 plus 2, which is going to be 2. Half of 2 is 1. Square root of 1 is 1. 1 plus 3 is 4. 1, 2, 3, 4. Just an easier way to do that. So here we go. So it's going to stretch it so it looks a little thinner. Now for the y-intercept, where it crosses, oops, I actually did that just now. X equals 0. So we're going to substitute that. Wherever you see the x value, it's going to end up being 0. So f of 0, 3 plus the square root of 1/2, 0 plus 2. Simplify, 0 plus 2 is just 2, half of 2 is the square root of 1. 3 plus 1 is going to give us 4. So we have a y-intercept which is going to be at 0, 4, which we just plotted. Okay. So if we just describe the parameter changes on this particular graph based off of our parent function, we would state that it would shift left 2, and then it would also shift up 3 units. Okay, and that 1/2 is going to actually make it a vertical compression. Because it's on the inside of the radical. Alright, so let's go ahead and take a look at a cube root. So when we're looking at a cube root, it is a little different because remember this graph is going to look more like an S shape. Okay, and the parameter changes are very similar to the square root, so we're going to still increase by 6 as far as the vertical shift, and then we're also looking at this, I could say that there's going to be a scale on the inside. That's just going to be -1, so it's going to go right 1 based off of that parameter change. Okay, where are there no real values for this function? Now, the cool thing about cube roots is the inside of the radical can be negative. So if it can be negative, then we can actually just make a statement that it has all real numbers. So just go ahead and state that this is all real numbers. Whoops. No matter what we have inside the radical, it will give us all real numbers. Okay, so if we're looking at the domain of our parent function, okay, so given the domain, no, I don't want you right now. Okay, domain would be all the x values. And as we continue to negative infinity this way, we continue to positive infinity the other way. This one is also all real numbers. If you were going to state the domain as an interval, you would just state negative infinity to positive infinity for the x values. So negative infinity less than x less than positive infinity. If we're given the range, remember those are the y values, same thing. On our parent function, it is negative infinity to positive infinity, and also, whoops, I didn't write the parent function up here. F of x equals the cube root. I'm going to write it down here. Of x. Alright, so when we give the range on our parent function, and this is for parent and transformed over here for D, it's going to be negative infinity to positive infinity. Same thing with our transformed. Negative infinity to positive infinity. And if we're looking for y, so f of x is y now, so we're just going to go ahead and substitute the equation. So wherever you see x is now 9. So we have the cube root of 2 times 9 minus 2 plus 6. Okay, so I just substituted 9 in, that's it. 2 times 9 is going to give us 18 minus 2 cube root plus 6. Okay, so we're going to go ahead and have 18 minus 2, which is going to give us 16, the cube root of 16 plus 6 equals f of x. Oh, no, f of 9. Alright, now the cube root of 16, we can go ahead and break that apart over here. So that's 4 times 4, 2 times 2 times 2 times 2. Okay, notice how we're looking for a group of 3 numbers that are the same. If we rewrite this as a square root, or a cube root, sorry, this would end up being 2 cube root 2 plus 6. All right, we cannot combine those, and if it was looking for a decimal answer, if we were supposed to graph this, I would actually just have you, at this point, put that in the calculator. So you're going to do the third root of 16. If your calculator does not do the third root, remember we can also translate this and rewrite it as 16 to the 1/3 power plus 6. So I'm going to go ahead and show you that on my calculator. And I'm going to do in parentheses 16, close parentheses, and I'm going to need the exponent key, so I have x of y, and inside parentheses is going to end up being 1/3, so I'm going to have 1 divided by 3, close parentheses. Remember, this is just calculating that 1/3. You have to press equals, and that's going to give you your cube root of 16, which is 2.519. I'm going to go ahead and round it to the nearest thousands, so 2 decimal places. So that's going to be 2.52. Okay, here we go. So that's 2.52 plus 6. I forgot to add that, so that's really 8 plus 52 would be f of 9. So at 9, the y value is going to be 8.52. All right, so the next step is we're going to go ahead and solve it if f of x equals 10. So now we're going to go ahead and substitute wherever you see f of x, it's now going to be 10. So I'm going to substitute 10 equals the cube root of 2x minus 2 plus 6. And I'm solving for x, which is on the inside of the radical. We're going to go ahead and subtract 6 instead, so that's going to be 4 cube root 2x minus 2, and at any time you can pause this and kind of play it at your own speed, okay, if you need to review a different topic. So if this is to the third root, I need it to the third power for that to simplify. I don't know why I drew the caret key, like I'm going to look at the calculator and actually do that. Okay, so that's going to be not to the 6th power, to the 3rd power. So this is going to be 4 times 4 times 4. Okay, so 4 times 4 times 4, that's 16. 16 times 4 is 64. Equals 2x minus 2. And then the next step is we're going to go ahead and add 2 over. That would just end up giving 66 equals 2x. Divide by 2, that's just going to give you 33. Okay, so x equals 33. When you're looking for an x-intercept, remember, your y value is going to be 0, so that's going to be y equals 0. Substitute that back in, so the y value is 0. So it's 0 equals the cube root of 2x minus 2 plus 6. Subtract 6 to both sides. We have the cube root of 2x minus 2. Next step is I'm going to go ahead and not do that. Okay, I'm going to cube both sides. Now when I cube a negative number, it's going to end up staying negative, so it's just going to end up being negative 6 times negative 6 times negative 6, which is negative 216 equals 2x minus 2. So I'm going to take negative 216, add to it, divide by 2. I would end up with 107 equals x. So that just means that it's actually going to end up being negative 107, 0. All right, now that we have found the x-intercept, we're going to go ahead and find the y-intercept. If you're looking for a y-intercept, remember x equals 0 this time, so we're going to go ahead and substitute it back in. This one is a lot easier because you're just looking for f of 0, so that's going to end up being the third root, or we could say the y equals, because we're really looking for the y-intercept, 2 times 0 minus 2 plus 6. So this is going to end up being 2 times 0. 2 times 0 is 0. Then we're going to have the cube root of negative 2 plus 6 equals y. There isn't a negative 2, the cube root of negative 2. So we're going to end up with a decimal answer, and that is okay. So we're going to do the cube root of negative 2 on your calculator. Okay, and then add 6 to that value. You should end up with 4.74 for y. So our ordered pair is going to end up being 0, 4.74. So when we sketch this graph, we're going to talk about the parameter changes. So looking at this, we already talked about the parameter changes up on the top. We're going to have a shift of 1 over and 6 up. So that's going to end up being 1 to the right and 6 up, 1, 2, 3, 4, 5, 6. So our graph is going to be way up here now. Another y-intercept is going to be 0, 4.74. So I'm going to go 1, 2, 3, 4, kind of halfway almost. So I know the graph is going to do this kind of curve. Now remember, our x-intercept is way out there somewhere, and that's steeping way too soon. So let me back up. So here's 1, 2, 3, 4, and 7. So that's going to go out. Okay, and it's also going to kind of curve up as well. Okay, so the parameter shifts that I really want you to focus on are just the horizontal and vertical for right now. Okay, so we know that it's going to shift right 1, and it's going to go up 6. Okay, so let's go ahead and take a look at our last apply it problem. So we're going to go ahead and apply what we know about irrational functions and solving irrational functions to the period of a pendulum. The amount of time needed for it to swing back and forth is given by the formula t of L equals 2 pi times the square root of L divided by 9.8. Now they tell us where L is the length of the pendulum. Okay, so that's the overall length. Okay, in meters, determine the period of the pendulum whose length is 0.5 meters. Okay, so if we're looking for the length, we're going to substitute 0.5 in for L. It is not asking you to do anything else. So it literally says L equals 0.5, and you're substituting it in. My cat says hi, by the way. All right, so I'm going to simplify on the inside before I do anything else. So 0.5 divided by 9.8, that's going to end up giving me a decimal that I'm going to keep in my calculator. Or if you have a calculator, you could just use the parentheses. Okay, so I went ahead and typed that in and I solved it out. 2 times pi times the square root of 0.5 divided by 9.8 is 1.42. Or if you go 3 decimal places out, or thousandths, it would just be 1.9. Okay, and that is going to take us seconds, because it says determine the period, and we know that the period is going to be in time. Okay, it doesn't say anything about seconds, but think about it. It's not going to be 1.5 minutes, it's 1.5 seconds about. So the nearest meter, the length of the pendulum, has of a period of 1.1 seconds. So if that means that the period is 1.1 seconds, this entire thing equals 1.1, okay, 2 times pi times the square root of the length of the pendulum divided by 9.8. Alright, now the next thing we're going to do is, because 2 pi is being multiplied, we're going to divide both sides by 2 pi. So I'm going to end up having 1.1 divided by 2 times pi. That's going to give me 0.175 to start with. I'm going to leave that in my calculator because when I square it, it'll be more exact. Okay, so I'm going to go ahead and square my answer. Just press the square key or take 0.157 or 175. Okay, and that's going to be 0.03064, but then that's going to just be the length divided by 9.8. So I'm going to multiply 9.8 to both sides. So that way it's isolated and we just have to find the length. So we're going to multiply by 9.8. And that's going to give us 0.30036, okay? But if we're rounding to the nearest hundredths of a meter, remember that's 2 decimal places out, so that would be 0.30, okay, meters. A third of a meter. All right, that concludes this lesson. Go ahead and work on your homework.